Hello everyone, I'm Johnny Wu from Innodisk's Intelligent Peripheral Application Division. Today, I'd like to share how we can turn AI's potential into real, scalable, and deployable solutions. We're living in the edge AI era, where computing power alone is no longer enough. We need to think about the entire ecosystem, how data flows, how memory is managed, and how software and hardware work seamlessly together. At Innodisk, we focus on building scalable AI systems and intelligent infrastructure that transform AI from concept into reality. In this talk, I'll show you how we leverage 4 key technology elements to help our partners overcome integration challenges and accelerate AI solution, creating smarter, more connected, and more efficient edge systems for the future. We see 2 high-potential markets where AI is creating real impact: industrial AI and enterprise AI. Industrial AI is all about reliability and durability. These systems run in extreme environments like factories, transportation networks, or medical facilities. They cannot fail, they must handle high temperatures, dust, vibration, and continuous operation. Enterprise AI, on the other hand, focuses on performance, scalability, and data security. When companies run large models with billions of parameters and serve hundreds of users, the system must scale efficiently and process huge amounts of data safely. Understanding these 2 markets helps us design flexible solutions that perform reliably at the edge and powerfully in the cloud. Our edge computing product line is not a single product. It's a complete ecosystem that covers both industrial and enterprise AI needs. For industrial AI, we provide compact, rugged embedded modules and box PCs that can handle real-time, mission-critical operations in harsh conditions. These are the frontline soldiers of edge computing. For enterprise AI, we offer high-performance edge servers and rack-mount platforms designed for large-scale data analytics and model inference. They deliver the compute and storage power enterprises need to run complex workloads. Together, these platforms create an end-to-end AI deployment framework from data collection to final decision and action. Innodisk enables our partners to unlock AI value across every layer of the system. Here, you can see our AI development ecosystem, built around 4 core elements that connect through what we call Edge AI in Loop. Sensing. Everything starts with data collection. About 80% of today's AI data comes from images. Without high-quality data, even the smartest model can't make accurate decisions. Storage. Once captured, data flows into storage. For large models like LLMs, storage now acts as a memory extension layer, easing memory bottlenecks. I/O. The bridge between AI and the physical world. It enables AI decisions to control devices instantly and precisely. AI software. The intelligence core that connects everything, managing data flow, optimizing performance, and orchestrating the entire system. These 4 pillars form the backbone of Innodisk's intelligent edge architecture. In edge and industrial environments, images make up over 80% of AI data, far more than text or audio. That's why image sensing is at the heart of accurate AI decision-making. AI's understanding of the world depends on what it sees. From factory defect detection to autonomous driving, image quality directly affects results. Our sensing system ensures AI sees clearly. It's not just a lens, but a full imaging pipeline built around. Lens defines what AI can see. Sensor captures the raw data and determines resolution, color, and noise. ISP processes data in real time, improving image quality and reducing GPU workload. Together, they give AI a reliable, high-quality eye to perceive the world accurately. When building a vision-based AI system, camera selection starts with understanding your platform and application scenario. Take a parking sensor as an example. Under bright sunlight, images can be overexposed, at night, too dark. That's where the sensor and ISP combination ensures consistent, clear visuals across all lighting conditions. Next, the platform interface is critical. MIPI is ideal for short-distance, high-bandwidth embedded systems. GMSL supports long-distance, multi-camera setups. Finally, all data streams into our edge compute platform, which handles fast, synchronized data input for GPU inference. This end-to-end optimization guarantees reliable image capture and efficient AI decision-making at the edge. Storage has evolved from passive data backup to an active memory layer in AI systems. Why? Because modern AI models are massive. Top models like Gemini 1.5 Pro now support millions of tokens, processing thousands of pages in one go. Each token consumes a lot of GPU memory. For a 70 billion model, each token may use 2.5 megabytes per second of VRAM. So while GPUs may have enough compute power, memory capacity becomes the true bottleneck. Innodisk addresses this with AI SSDs and tiered memory technology, turning storage into an intelligent, cost-efficient memory extension that supports large context AI processing. Let's take the Llama 3 70 billion model as an example. Serving 100 concurrent users with 2,000 tokens each requires over 520 GB of memory. Even with 4 NVIDIA A6000 GPUs, we only have 192 GB of VRAM, far from enough. Simply adding more GPUs doesn't solve the problem. The real solution is to combine DRAM and SSD into a dynamic, tiered architecture. In this setup, the GPU keeps only the most active data in HBM memory, while less critical data stays in SSD or RAM and moves in real time with minimal latency. This approach breaks the VRAM limitation, reduces cost, and enables scalable LLM deployment, making large model AI truly practical for enterprise use. I/O is the hands and feet of an AI system, turning digital intelligence into physical action. Look at the edge applications on the left: humanoid robots, AGVs, and forklifts. Each has unique I/O requirements. EtherCAT for ultra-fast industrial motion control. MIPI over Type-C and GMSL for high-speed imaging. CAN bus for autonomous and vehicle communication. I/O modules extend platform compatibility, allowing one AI system to communicate with diverse devices, old or new. In short, I/O integration ensures AI decisions can directly control real-world equipment with precision and reliability. Now let's move from hardware to the heart of intelligence, AI software. Software transforms powerful hardware into a truly intelligent system. Traditional AI agents automate tasks but rely on human commands and can't adapt easily. The next step is agentic AI that can plan, decide, and act autonomously. Instead of one static brain, it's a network of agents with shared goals. They can break down objectives, call the right tools or I/O interfaces, and adapt when conditions change. Our framework provides the foundation for this evolution, enabling AI systems that think, plan, and continuously improve on their own. So how does an agentic AI actually work? An agent receives a goal, while the LLM plans and reasons through the steps to reach it. At the center, our MCP server runs the inference engine. It translates abstract AI instructions into physical actions through a function API layer. This means AI can not only analyze data but also control devices directly, sensing, thinking, and acting in a complete loop. This architecture marks the beginning of fully autonomous AI operations that integrate intelligence with action. Let's see how it all comes together. Our Innodisk AI software stack is the foundation that connects hardware, software, and business logic into one intelligent system. At the base, the hardware module adapter layer abstracts I/O and storage into standard APIs. The runtime environment layer ensures compatibility across NVIDIA, Intel, and Qualcomm platforms. Above that, the service and agentic AI layer hosts the MCP server and LLM reasoning engine. At the top, business logic connects everything to real-world applications like smart retail, monitoring, and device management. This full vertical integration turns complex, heterogeneous hardware into a unified, intelligent ecosystem enabling faster, more scalable AI deployment. Here's a real-world example. Our system monitors all edge devices. When an agent detects that a CPU temperature exceeds 75 Celsius for 30 minutes, it doesn't just raise an alert, it investigates. Using the Innodisk AI Stack SDK, the agent checks fan speed via I/O, reviews SSD and DRAM temperature, and analyzes 24-hour historical data. It concludes the issue is caused by dust buildup on the heatsink. Then, it takes two actions. 1. Lowers CPU frequency to bring temperature down. 2. Creates a maintenance ticket in ICAP and notifies engineers automatically. This shows how our AI moves from passive monitoring to active problem solving, a true example of autonomous intelligence. To wrap up, this final diagram shows Innodisk's position in the AI ecosystem. We are not just a hardware vendor, we are the intelligent architect of edge AI. We design the blueprint, integrate the building blocks, and solve the hardest system challenges, from KV cache bottlenecks to multi-camera protocols and cross-platform compatibility. Our mission is to help customers deploy AI faster and smarter, without worrying about complex hardware integration. Innodisk provides the blueprint, the modules, and the expertise to turn AI innovation into real-world success. Together, we're building the foundation for the next generation of intelligent infrastructure.